So in order to refining the sketch for the root locus, actually we have the general root locus sketch in the previous, as we see in when we apply the 5 rules. So if we want to highlight or if we want to complete the root locus and identify some of the crossing point, some of the intersection with the imaginary axis, breakaway and breaking point, as we said here, we said this one is not complete actually, or this figure is not complete because uh, there is some point we do not highlight, like as we mentioned before. For example, what is the intersection with the imaginary axis? Because this root locus will go to imaginary axis. There is some intersection point we don't know how to find until now. And also, what is this point where the root locus go out from the real axis? We don't know this point also. We know the centroid, but we don't know the point of breakaway here. And if we have some imaginary or I mean complex roots, like complex pole or complex zero, we need to know something. We call it departure and arrival angle of the pole and zero. So in order to perform such refining for our root locus sketch, we need to apply the rest of rules, which is rule to number 6 until rule number 8. So rule number 6 is more related to the real axis breakaway and break-in point. So for rule number 6, it's specific for real axis. We are not talking about the root locus in the imaginary part here, or in the part which has complex numbers. Our focus only on the imaginary real axis intersection here. So we have two type of points. One we call it breakaway point, the other is break-in point. So what is the difference between breakaway and break-in points? The difference is breakaway is the when the root locus leave or out or exit from the real axis. So you can see the direction of arrow here. So the direction of arrow for both sides is leave or exit from the real axis. So for that we say breakaway. Okay, but here the direction of the arrow in the root of the root locus is go inside the real axis, so it's come from somewhere and go to the real axis. So for this one we call it break-in point. So this is the difference between breakaway and break-in point. Usually the breakaway point is exists between two poles. So if you have two poles on the x-plane, there is one pole here, another pole here on the real axis. In between them, we should have a breakaway point. So we should have one point here for breakaway point. Okay, anywhere in this area between the two poles. So breakaway point exists between two poles, while break-in point exists between two zeros. So you can see here, this is 1 0, this is 1 0. In between them, we have break-in point, which is here. Okay, so breakaway point between two poles on sigma axis or real axis. Break-in point between two zeros on real axis or sigma axis. Okay, both they are exist on the real axis. So we are not talking about the poles or zero are placed in this area, complex or imaginary or so on. No, we are talking about poles and zero which place on the real axis or on the sigma axis here. Okay, so now we know what is the difference between breakaway and break-in point, but we don't know how to find these points, how to calculate these points. What is this point? If this one is -2, this one is 0, how I know this point is -1? When I have the root locus like I saw in the previous figure here, now I know this point, which is for example it is 0. I know this point is -1, but I don't know what is the point here. So this we call it breakaway point. How I can know what is the value here? Is it 0.5, 0.6, 0.7, 0.8 in negative actually, because we are talking about the negative axis here. Okay, so here we need to know, or here we need to learn how to find this point. Actually, according to the characteristic equation, which is kgshs plus 1 equal to 0, or kgshs equal to -1, the value of k here can be calculated based on this formula. So we can use the value of k here in order to calculate the value of the breakaway and break-in point. So by drive, for differentiate here, by differentiation of the dk over ds, now we have k here, we need to apply differentiation, derivative, okay? So differentiation here, we are going to make dk over ds. We are going to drive k with respect to s. The derivative of this k with respect to s will give us some values here, or equations. We make this equation equal to 0, because why we make it equal to 0? Because actually k is a constant number, k is the gain. So when you drive d5 over ds, for example, will give you 0. d100 over dx or over dy, for example, equal to 0 also. So whatever is the number that you are going to drive to find the derivative of it, so it will be 0 because it's a constant number. For that, the derivative of dk over ds, which is the derivative of this function, which consists from numerator and denominator, will equal to 0. Then we are going to solve this equation in order to find the value of s, and the value of s here represent the value of sigma. Why s equal to sigma? Because usually s is represented by complex number. So s equal to, when we talk in the beginning of this chapter, we said s equal to sigma plus minus j omega. So we have three cases for s. Either s is a real number, so in this case s will equal to sigma, and this one omega equal to 0, or s is a pure imaginary number, so s will equal to j omega, okay, or s is a complex number, which is s equal to sigma plus minus j omega. So these are the three cases for s. Now, after we write this equation, we need to solve for the value of s, so we can know the value of s must equal to sigma, because we are talking about the real axis, or I mean the intersection or the cross. The breakaway always here is a real number. Along this axis, all the value are real. Along this axis, all the value are imaginary. In this area, the value are complex. Okay, so this is the different value of s can be represented here. Okay, either real, imaginary, or complex. But in the case of breakaway and break-in point, our focus will be on the real number. So because it's on the real axis, so this point should be real number. That point also should be a real number. So after we drive k with respect to s and we make it equal to 0, we are going to solve for s. Then we find the value of s. For example, s equal to -5, s equal to 0.25, s equal to, I mean, any value. We are going to find the value of s. These values of s represent the crossaway and cross-in point. The solution for this equation after we drive with respect to s will be the value of breakaway and break-in point. How we identify which one is breakaway, which one is break-in? We said breakaway is placed between two poles, break-in is placed between two zeros. Okay. Later on, we will see one example to use the differentiation method in order to find the value of breakaway and break-in point. Another method, there is another method without using differentiation here. So what we are going to do, we are going to apply this formula. We put the zeros on one side, summation of zeros and summation of poles, like this one, summation from 1 to m, 1 over sigma plus why sigma, because we said the value of s here equal to sigma. It is a real number. S is a real number for breakaway and break-in point. So here also sigma same. So 1 over sigma, I mean, if you have 1z, so it will be like 1 over sigma plus 1, for example. If z, you have 2z, 1 and 2, so it will be 1 over sigma plus 1 plus 1 over sigma plus 2. Whatever is the value of z, you are going to substitute here. Whatever is the value of poles, you are going to substitute here. and then you have one equation. You simplify this equation, you solve this equation to find the value of S, which will give you two values. One is the breakaway, one is the break-in point. Okay, so we are going to see how to find this breakaway and break-in point within example. And in this example, we are going to use the two methods. One, using the differentiation method. The other one using the formula 1 over sigma plus z equal to 1 over sigma plus b. This is the example actually. We assume that we already have this root locus, and this root locus, it has breakaway and break-in point. So at this point we have breakaway point. Why breakaway? Because it's between two poles, which is -1 and -2, all cross mean poles. So this will be breakaway point. And here we have break-in point. Break-in point because it's between two zeros, which is 3 and 5. So we have two zeros. In between them we have a break-in point, and we have two poles, and in between them we have a breakaway point. Okay, so these are the 2 points that we want to find. This is the breakaway and break in, and here is the breakaway. Okay, so actually this root locus is not come by itself, it's come according to the transfer function. And the transfer function of this equation is like this one, or the forward transfer function is k s minus 3 s minus 5 over s plus 1 s plus 2. So we have two poles at -1 and -2, and we have two zeros at at +3 and +5. Okay, so this is +3, this is +5, this is -2, this is -1 are the poles. Okay, now this is our transfer function. I mean the forward transfer function. It's like this one, k s minus 3 s minus 5. This is the numerator. The denominator will be s plus 1 s plus 2. Okay, now we want to find the value of this at this point. This point is not 1.5, it's not -1.5, it's not -1.4. We don't know the point here exactly. We want to find it. Our objective in this example to find this point, then to find that point. So we have two methods, one using the derivative method and the differentiation method. So we are going to find the value of k in terms of this transfer function. Then we are going to derive the value of k with respect to s and equal to 0, then solve the equation to find the value of s, which is a real number. So here we can, as we can see here, the condition for the root locus, or for the point to be a part of root locus, is from the equation kgshs equal to -1, or the magnitude here equal to 1, the angle equal to 2 pi plus k times 180, correct? So what you are going to do here, we are going to solve this, substitute the value here. This is the value k is and equal to -1. Why equal to -1? This is from the condition of the characteristic equation, actually, because the characteristic equation is 1 plus kghs equal to 0, correct? Or kghs equal to -1. So this is the equation here. Now we are going to substitute for this value from this equation. So this part will be substituted here. So now k, actually this we need to open this one in order to simplify the derivative of that equation. So s times s will give you a square, s times -5 will give you -5s, -3 times s will be -3s, so the total is -8s. -3 times 5 it will be or times -5 it will be +15, and here when we open it become like this one, s square plus 3s plus 2. So we just open it in the form of polynomial here. It's not in the form of the roots. So the equation become like this one, k sigma square -8 sigma plus 15 over sigma square plus 3 sigma plus 2. We just replace s here by sigma. Why? Because we said our value are on the real axis, so for sure it will be a real number. Since it is real number, so it's on the sigma axis or on the real axis. So the value of S here will be sigma. It's for that we call it negative sigma 1, sigma 2. Okay, since the value are real, so it will be sigma only, no j omega, no compilation or complex number. So you just substitute for S by its real value, which is sigma square. So now we find the value of a k from this equation, actually equal to -1. So k equal to -1. It's like to find the derivative here, cross multiplication, then we find k. So k will equal to negative sigma square 3 sigma plus 2 over sigma square minus 3 sigma plus 15. Now this is the value of k, but in the derivative method or in the differentiation method, we need to derive dk over ds. So we need to derive this one with respect to s. So d over ds for this part with respect to s. Actually, this equation, it looks when we have a fraction equation which consists from polynomial, I mean numerator and denominator here. If I want to find the derivative for this equation, d over ds for this equation, what is the formula said from calculus here? D over not only ds, d over anything, dy, dt, dx, dz. If I want to derive the friction function, so the solution or the answer will be here for friction method is the square of the denominator, which is b square, then denominator times the derivative of numerator minus numerator times the derivative of denominator. So this is the formula actually. The formula for derivative friction function, it can be like this one. So again, just I want to remove all. Okay. So the formula said, if you have a function, for example, which is a function consists from fractional method, which is numerator and denominator. So the a is a function, b is a function, combination of both is also a function, f of x, for example, or any. If I want to derive this function, actually, the formula said square of the denominator times prime or derivative of numerator minus numerator times derivative of denominator. Okay, whatever is the value of a, whatever is the value of b, we are going to drive it for any value we want to drive. For in this case, we are going to drive with respect to sigma. Okay, so if I want to drive this function dk over d sigma or dk over ds, if it's s, so if it's sigma, just put d sigma. I need to apply this formula here. So the value of a here is equal to negative sigma square plus 3 sigma plus 2, and the value of b is sigma square minus 8 sigma plus 50. So if you just apply this formula here in order to find the derivative, so b square means this is b square, so it will be sigma square plus minus 8 sigma plus 15. This is b square, it is square. Then we are going to take b, which is this value, times the derivative of a. So we can just write b here for simplification. B, later you can substitute for the value of b, times the derivative of a. So the derivative of a here, a is equal to this value, correct? So the derivative of a will be negative 2 sigma plus, or negative, this negative will go inside, negative 3. Okay, minus, so b times a prime minus a, you just put a, later you substitute, times b prime. So the prime or the derivative of the denominator here is 2 sigma minus 8. So it will be 2 sigma minus 8. Okay, so this will be the derivative of dk over ds here, dk over d sigma or ds. Okay, now you just need to substitute for the value of b, which is sigma square minus 8 sigma plus 15, and you substitute for the value of a, which is negative sigma square plus 3 sigma plus 2. You substitute here and you simplify. Solving, after you simplify the equation here, you are going to make this all equal to 0. Why equal to 0? Because we said the dk over d sigma here. When I derive a constant number, which is k, which is the gain, over any variable, so it will give you 0. So if this one is 0, this will become also 0, because we are going to multiply cross multiplication. So this one will be 0 and that one will be 0. Okay, so if this one is 0, just simplify this part. You are going to find an equation which is like this one. When you simplify this part, you are going to find it like 11 sigma square minus 26 sigma, after you substitute for a and b prime, okay, plus minus 61, okay, equal to 0. Why equal to 0? Because this already 0, so if you make cross multiplication, this will be 0, and this will equal to 0. Now you solve this equation. This is two or second degree ordinary equation with one variable, which is sigma. You just solve for sigma. So sigma has two value. You can use your calculator or use the formula negative p plus minus p square minus 4ac over 2a. So you use this equation or you use the calculator. You are going to find the solution for sigma is two values, which is negative 1.45 and positive 3.82. So from these two values, one of them is break-in point, one of them is breakaway point. How to know? From the graph here. It's easy for you now. If I ask you now, where is, I have here break-in point, I mean breakaway point. So the value here is in negative bar, so it must be negative 1.45. So this value will be negative 1.45. The other value is positive, so it shouldn't be here. So it should be on the other side. So this will be the positive, which is between 3 and 4. So it will be 3.82. Okay, this is how to use the differentiation method in order to find the value of breakaway and break-in point. So this is the breakaway point, this is the break-in point. We calculate the two values on the real axis. We said why we use sigma, because sigma represent the number or the integer, the real number on the real axis, while j omega represent the number on the imaginary axis. We can resolve this equation, I mean, or to find these values by using the second method, which is depends on this formula actually. So according to this formula here, we are going to substitute the values of the zeros and the value of the bulls in this equation. So we are going to take this equation and substitute for the value of 0 and the value of bulls from this equation. So we have s negative 3, s negative 5. So this will be on the left side, and we have s plus 1, s plus 2, so this will be on the right side, as you can see here. So but we replace s by sigma. Why? Because we said s here will be a real number which is on the sigma axis, so it will be a sigma number. So each s will be represented by sigma. You can keep it s same. You are going to solve for s, or you convert to sigma, so you are going to solve for sigma. Okay, so 1 over sigma minus 3, this is for 0. This is the first 0, which is z1. This is the second 0, which is z2. This is the first pole, which is p1. This is the second pole, which is p2. Okay, so we substitute here. Then we simplify this equation by by adding them as a fraction here. So you have to take a common sigma minus 3, sigma minus 5 as a common, and you solve for the left side. Also for the right side, you simplify, you are going to get the same equation, which is 11 sigma square minus 26 sigma equal to 0. After you take all this part to the left side, you still have here 0 only. So this is the 0 here. You simplify, you solve this equation, second order equation actually, with one variable, which is sigma. For sigma, you use any method, so you are going to find the value of sigma here, which is the break-in point and the breakaway point. Okay, so this is just another option, or another option to solve the equation. So it's up to you in the exam you want to use this method, you want to use the differentiation method. So it's up to you. I mean, try to find which is the easiest for you to in order to find the breakaway and break-in point. But always remember that breakaway and break-in point are only exist if you have two pools without anything between them. There is no zero between them. So in this case, we have breakaway point, or you have two zeros without any balls between them. So in this case, we have a break-in point. Okay. So this is the idea or the concept of breakaway and break-in point. Breakaway point, you have two balls on the real axis, and there is nothing in between them. So in this case, we have breakaway point. If you have two zeros on the real axis and you don't have any balls in between them, so you should have a break-in point. This is the rule number 6. We move to the rule number 7, and rule number 7 actually is more on the intersection with the images. So our focus will be where our root locus will intersect or will cross the imaginary axis, and this is very important point actually. Why this is very important point? Because as we said before, when the root locus start, it will start at the pool, correct? So if the root locus start at the pool, the value of k at the pools equal to 0, as we explained before in the previous lecture. When we said the value of k will change from 0 at the value of pool, then it move to another values based on the pools of closed loop transfer function, as we mentioned in the example of the table that we see in the beginning of this chapter. There is a table, we see how the value of k change from 0 at the pool point, then it's go to other values, the gain will increase. With changing the gain, the root locus will move. When the root locus reach to the cross with the imaginary axis, so in this case the bulls will be moved to the right side. If the bulls on the right side, that means the system will be unstable. For that we said this cross point is very important point, because this will change the system from stability to the instability. So on the left side the system will be stable, on the right side the system will be unstable, on this point the system will be marginally stable. Okay, for that we need to identify when the root locus will cross the imaginary axis, so our system will be changed from the stable case to the unstable case, from stability to the unstability. Okay, so in this rule we are going to learn how to find this value. Actually we already talked about this cross section in chapter 4 when we talk about the root locus. So rough table. Here we are going to repeat the same. So we are going to use the rough table here. We are going to use the route table in order to find the crossing with the imaginary axis. What we need to do, we just need to write the equation for characteristic equation. After we write the characteristic equation, we construct the rough table. When we construct the rough table, we are going to find the value of k, which make our entire row is zeros. You remember we have two cases. One, the first row is 0. There is 1 0 in the first row. The second is we have entire row of zeros for rough table here. When you have S3, S square, S0, then if we have 1 0 only here and then we have number, so this is, we call it case 1, and we apply the epsilon method in order to find the to identify system stability. Or we have entire zeros, entire row of zeros, so in this case we are going to apply the polynomial. We go to the previous line and so on, and we are going to find the value of s or another polynomial for s in order to solve or overcome this issue to continue identify system stability. So we are going to see here from if we have this characteristic equation, actually our 1 kgs equal to 0. This is the common characteristic equation for all system in the case that hs equal to 1 for unity feedback system. So the gs here is, this is the open loop transfer function, which is 1 over s plus 1, s plus 2. In this case Actually, if we want to use the rough table, we need to open this equation, the characteristic equation, and write the characteristic equation in the form of polynomial here. So we have s cubic plus 3s square plus 2s plus k. After we make the, this is for open loop transfer function, okay, which there is no zeros. We have 3 poles. This is open loop. If we want to find the closed loop, so it will be like this one: gs or kgs over 1 plus kgs hs. Hs equal to 1, so it will be kgs. That means our gain will be increased by the value of k. So when we open this one, s times s square times s kq s cubic, s times s square times 2, so 2s square, s times s square 3s square, 1 times s, 2 times s, we have 2s here, and we have the value of k or of the gain will be added to the rough table. To be more clear about this one, you can refer to the chapter 4 when we write the characteristic equation for the closed loop transfer function. Okay, after we write this equation, now we need to construct our rough table. So our rough table here, it will be like this one: s cubic, s square, s, s0. Then we write the coefficient for s cubic here, which is 1. The coefficient for s is equal to 2. The coefficient for s square is equal to 3. The coefficient of s to 0 is equal to k. Okay, so now we need to continue here. We need to write the rest of this coefficient based on our equation, which is the matrix, which is 1 3. Then we have 2k here over negative over 3 or negative. Then we find the second one here according to this value. So in this case, you are going to have a value here which is 1 times k minus, 1 times k minus 6, and this will be multiplied by minus, so it will be like 6 minus k. So you are going to have here 6 minus k over 3. So this will be the variable here, or the value of this element. You just go revised for rough table. So the value here, where we just apply, use the determinant here. So this will be like this one: 6 minus k over 3 in this value. 6 minus k over 3, and here it will be 0. Why 0? Because we are going to put 0 here. The 0 will be open 0. So there will be a value here for k which make this element equal to 0. If k equal to 6, so 6 minus 6 equal over 3, so it will be 0. Now 0 and 0, we have entire row of 0. So in this case, we need to go for the previous line to write the characteristic equation for the previous line. So the characteristic equation, or the equation for the previous line, so it will be like 3s squared plus k. This will be the equation. We need to drive this equation, so we have 6s equal to 6s here equal to 0. Equal to k here. Sorry, the value of k here already, if we make k equal to 6 here, so we are going to find 0. So the value of k will be replaced by 6 here. So it will be 3s squared plus 6. Okay. So this will be the equation: 3s squared plus 6 equal to 0. So now we need to drive this one, so it will be 6s only. So as we can see here, so 3s squared plus 6. If you have 3s squared plus 6 and you want to find the polynomial here, you need to drive, so it become like 6s. So the 6 will be represented here, in this line, and this will be 0. So this will be how to replace the value. But you write that's just the equation here: 3s6 plus 6 equal to 0. Then you solve for s. 3s square equal to negative 6, or s square equal to negative 6 over 3, or equal to negative 2. So s square equal to negative 2, those s will equal to plus minus set 2, because if I want to find s square here, that means I will replace the negative here by j square. So set for s square, set for this one, so it will give you plus minus j2. Okay, so the value of plus minus j2, that means the intersection here is plus j2 and the intersection here is minus j2. Okay, so these are the two intersection points for the rule number 7. So from these two that means our system will be stable until the value of k when we have the value of k at this point here change to this value, so on the right side will be our system will be unstable. Why? Because we still have we start to have some poles which is positive poles. So, and we said previously, if we want our system stable, the poles should be all negative poles on the left side. If you start to have at least one pole on the right side, so your system will become unstable. At this point, actually, the value of k it has or the value of the gain it has or the gain it has a value, so we can calculate the value of the gain here. And as we said here, we said the value of the gain is equal to 6. So the value of the gain of 6, which will make the system is marginally stable. After that value, if we increase the gain, so we are going to have a negative root on the right side. So if the root on the right side or if the pole on the right side, so our system will be unstable. This is how to find the intersection with the imaginary axis. And if we want to apply, later on we are going to have a complete a complete example about the sketching the root locus to apply the 8 rules. Now until now we already apply 5 rules, then we learn extra 2 rules which are the break in and breakaway points and also the crossing with the imaginary axis. The last rule here, it's more related to the complex pools. Complex pools means your value of pool will not be a real number. It should be like 2 plus j3, 5 plus j6, any number which consists from real part and imaginary parts. In this case, the pools will not placed here and the zeros are not placed here. No, the pool should be in this area. Whatever either pool or zero, it will be in one of the quarters. This we call it quarter 1, quarter 2, quarter 3, quarter 4. So the pools or zero will be placed in this area. That means S will be in the form of a sigma plus minus j omega. So S will have real number and imaginary number. It consists from two parts, real and imaginary. So if S consists from two parts, real and imaginary, it should have a magnitude for S which equal to sigma square plus omega square root 2, and it should have angle S. So the angle of S here or theta is represent the departure or arrival angle. So if it's pool, so it will be departure angle. If it is 0, it will be arrival angle. Okay, so we have arrival here, we have departure. So if it is a pool, it will be departure. Why? Because usually the poles or the root locus will leave the pool, go out. Where? Toward the 0. Start from the pool, go out towards the 0. So usually if this is a pool and this is the root locus, it will departure by using departure angle or PP. Okay, so this we call it departure angle. If our 0 is located in the imaginary and in complex number, so it has arrival angle. So the root locus is come from this point, arrived here. Okay, it will arrive by using arrival angle. This arrival angle we call it PZ. Okay, P for pool, Z for 0. Okay, so this is how what's the difference between the departure and arrival angle. And we said if your pools are real, you don't need to calculate the departure and arrival. If the pools all if all pools and zeros are located on the real axis, either positive or negative, no need to find angle of departure and arrival. But if you have at least one pole or one zeros in the quarters, that means it has a complex number, it is real and imaginary. So in this case, if it's a pole, you need to find the departure angle. If it's zero, you need to find arrival angle. Okay, so usually when we calculate the arrival or departure angle, we calculate them with respect to the horizontal line or the vertical, the horizontal axis, which is the real axis. So always we calculate angle of departure in this way. This is more details how the angle of departure and angle of arrival are looks like. So in this case, we have poles on the complex or complex poles. We have a real poles here. This is real pole. So for this one, no need to find the departure and arrival angle. But for this pole, yes, we need. So this is the pole, and here we have another pole here. And we said since our root locus should be identical or symmetry around the real axis, so you have here pole, for sure you have here pole. So if you have, for example, 2 plus J3, you must have 2 minus J3. So it should be like two poles. You cannot have one complex pole only. So always be 2, 2. For example, and you have here another, you have a 0 here, and also you have same, you have 0 on the other side. Okay, so in this case, if we focus first on the angle of departure, so we are talking about this pole, and we want to know what is the departure angle of this root locus at this pole. So we are going to find this angle here. So the departure angle here, which is theta 1, it can be calculated according to this formula. Departure angle is equal to 180, which is a constant here, plus angle of zeros, summation of angle of zeros. How many zeros do we have? We have 3 zeros. So we are to add or sum the or find the summation of the 3 angles of zero. Angle of zero here, theta 6, theta 2, theta 3. We are going to add them. So angle summation of zero here will be like theta 2 plus theta 3 plus theta 6 minus summation of angle of poles. If we are talking about this pole, so the rest we want theta 5, theta 4. If we want to find for theta 5, we are going to add theta 1 and theta 4. Okay, so this one here in our case will be theta 4 plus theta 5, because we are going to find pb here. Pb here represents theta 1. Okay, so if you want to find theta 1, it will be like this one: theta 2 plus theta 3 minus theta 4 minus theta 5 plus theta 6 minus 2k plus 1, 180. Why 2k plus 1? Same, it can be like multiple odd of 180. So k equal to 0, it will be 180, k equal to 1 will be 380, and so on. So the summation of all angles here, if you remember in the beginning of this chapter when we talk about the vector, we said vector always has length and has angle. So when we calculate the angle for vector, we need to draw line from all points to the point of vector that we want to find. So we draw this line, we find what is the length of that one, 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 the length of that one. So this is, we call it the length of vector, and we find the angle for each one with real axis. So this is the angle is theta. Here we have the angle of theta 4. Here we have the angle is theta 3, theta 5, and theta 2 also. Okay, so this is how to find the angle of departure. Regarding the angle of arrival, it's almost the same. So but angle of arrival is more related to 0, while angle of departure is related to the pole. So if we want to find the angle of departure for theta 2, for example, here this is a 0, and we have departure for the root locus, and the angle of departure is the angle with the horizontal line or with the real axis, or line is in parallel with the real axis. So this is the value of theta 2. So we need to apply this formula, which is theta z here equal to 180 plus angle of poles minus angle of zeros. So in the previous one, it was plus angle of zeros minus angle of poles. Here, no, it's opposite. It's plus angle of poles minus angle of zeros. So if we just apply this formula here, or we can replace it by the formula of 2k plus 1 same here on the right side, and here we add all angle of poles and angle of zeros. We want to find theta 2, so we are going to substitute theta 2 will equal to summation of angle of poles minus summation of angle of zeros plus 180, or any odd number of 180. So in this case, we can find the value of or the angle of arrival for a complete. Both arrival angle and departure angle are related to complex poles only. Complex poles. If you do not have complex pole in your transfer function, no need to calculate angle of arrival and angle of departure. If you do not have two poles in the real axis without any rows between them, so no need to find breakaway and breakpoint. Okay, that means you must have two poles on real axis, you must have two zeros in order to find breakaway and breaking point, you must have complex poles in order to find, or complex zero in order to find angle of departure and angle of arrival. You must have crossing with the imaginary axis in order to apply the rule number 7. So the three extra rules, I mean rule number 6, 7, 8, this we are not apply them always. Okay, there is some condition we need to apply, depends on what is the status, or what is the value of your transfer function. So if there is two poles are in sequence and there is no zeros in between them, so in this case we are going to apply rule number 6. If you have crossing with the imaginary axis, so in this case we are going to apply rule number 7. If you have complex poles or complex zeros, so in this case we are going to apply rule number 8. Otherwise, no need to apply. Okay, but the first 5 rules you need to apply all the times in order to draw the overview or the overall root locus of your transfer function for the control system. Now we are going to solve one example to apply the 8 rules on this transfer function. To draw the root locus using the 8 rules.